Hello everyone. Again, I am Jericho Manalo, your winning student. We are now on the part 2 of the video discussion regarding sampling. And in the previous discussion, ginamit natin ang sample data as a means of estimating the population parameters. But actually, ginagamit din ang sample data to test hypotheses about population values. Yung procedure para dito sa testing incorporates the same information as in interval estimation. Pero yung goals behind the two methods are somewhat different. Balikan natin yung example doon sa average dollar value purchases ng mga customers sa department store. Pero ngayon, gawin natin is alamin whether or not pareho lang yung average amount in purchases ng mga customers sa Department A at sa Department B. In the research process, step number 5, nalaman natin na unang sineset yung null hypothesis, kung saan sinasabi na walang pinagkaiba yung ini-expend na dollar values ng mga customers sa dalawang department stores. We can express that as H subscript 0 is equal to population mean A minus population mean B is equal to 0. Then, yung alternate hypothesis naman will be stated non-directionally as H subscript A or yung alternative is equal to the population mean A minus population mean B, wherein yung difference is not equal to 0. Ngayon, if we take 20 customers as samples from each of the two stores, and nalaman natin na yung mean dollar value sa store A is 105 with a standard deviation of 10, tapos dun sa store B naman, yung mean dollar value is 100 with a standard deviation of 15. Therefore, makikita natin na kapag pinag-minus natin yung dalawang mean, may makukuha tayo na difference na 5. With this, pwede na ba nating makonclude or i-conclude na accepted yung alternative hypothesis natin? Of course, hindi muna. Because we need to determine first yung likelihood ng dalawang group. And this can be done by converting the difference in the sample mean to a t-statistics. By the way, na sa ganitong example na hindi natin alam whether yung difference between the two stars will be positive or negative, gagamitin natin is two-tailed test. Otherwise, kung hindi naman, yung one-tailed test. Magkaiba kasi yung t-scores na makukuha natin dun sa mga test na yun, wherein sa case natin ngayon, mahanap natin na yung critical value should be around 2.021 if 95% confidence, and kapag 90% naman yung probability na gusto natin, it should be at least 1.684. Makikita natin to dun sa t-table. Now, let us see kung ibang makukuha nating t-scores given those data provided kanina is nasa 90% or 95% or way lower ba before natin makonclude kung bang meron silang significance. And ganito yung ating solution. Kinopya ko lang yun dun sa reference natin. Medyo mabigat lang sa mata, pero actually, substitution lang naman yung ginawa rito. Kung ayaw nyo naman na mag-solve ng manual, pwede naman, kasi meron namang mga t-scores calculator and other statistical tools sa net na pwedeng gamitin para mapadali ang buhay. Pero for now, tisin muna natin itong binigay sa example. So, nahinto yung computation sa T is equal to the mean A minus mean B minus the difference of population mean ng A at B all over 4.136. And alam naman natin na yung mean A minus mean B is equal to 5, yung kanina. At yung population mean minus A minus B is equal to 0 or yung ating null hypothesis. Then, yung t-scores na natin will be 1.209. And it is way below sa critical value na 2.021 na 95% confidence level at kahit doon sa 90% probability na nagre-require ng value na 1.684. Thus, we therefore conclude na yung difference na 5 na nahanap natin sa pagitan ng dalawang department stores is not significantly different doon sa they are not significantly different. Kaya, we will now accept yung null hypothesis na natin and reject naman natin yung alternative hypothesis. Mas may encounter natin yung mga ganitong hypothesis testing sa mga susunod pang reporters. For now, enough na muna na na-present natin yung example. Ipinakita lang na hindi lang natin nagagamit sa sample data in estimating the population parameter but also dito din sa hypothesis testing. Kaya pa ba? Hinga muna tayo sandali. So, pwede mo munang i-post yung video para naman makainom ka dyan, kumain or mag-CR. After that, tuloy na natin sa last topic, which is yung sample size. And there you go. We are now in the determination of sample size. Pero bago yon, ano nga ulit yung ibig sabihin ng sample size? It is the number of observations taken from a population through which statistical inferences for the whole population are made. In short, these are just samples that will represent the whole population. Since aware na tayo na ang sample size ay governed by the extent of precision and confidence, ang tanong ngayon is how do we determine the sample size para sa mga research natin? So ngayon, let's start answering one simple problem wherein hatiin natin siya sa 3 cases. So, basahin lang natin. Suppose a manager wants to be 95% confident that the expected monthly withdrawals in a bank will be within a confidence interval of $500. Let us say that a study of a sample clients indicates that the average withdrawals made by them have a standard deviation of $3,500. What would be the sample size needed in this case? So, para makuha natin yon, the first thing to do is always list the given data. Sorry, hindi natin yun na sunod dun sa kanina, pero ayun nga, mas maganda na gawin muna natin na i-list down yung mga data na binigay sa problem, plus aalamin natin yung tanong or yung hinahanap para mas segregate na natin yung mga relevant sa hindi relevant. And dito nga, we have the confidence level at 95%, tapos binigay yung confidence interval na $500 at standard deviation na 3,500. With this, we can solve for the standard error, yung S subscript X mean dyan by dividing the confidence interval to the K value of the confidence level. And there, we get 2.55.10. After that, pwede na natin isolve yung sample size by squeezing the formula na standard error is equal to the quotient of standard deviation and the square root of n or yung sample size natin. I advise na gumamit tayo ng scientific calculator sa ganito para hindi ganun mahirapan lalo na at may mga radical signs tayo dito. And ayun, after some pindot-pindot sa calculator, we will get 188 and ito na yung ating sample size na required. And ito yung sa case number 1. Ngayon, sa second case naman, sinasabi na paano kung yung total clientele ng bank is only 185. Sobra pa ng 3 yung nakuwang sample size natin kanina kumpara dun sa whole population. Ano na ngayon ang gagawin natin? What is the sample size now using the same confidence level? Kapag ganito yung scenario, sabi dun sa reference, need nating mag-apply ng correction formula and ayun nga, it is computed as standard error is equal to standard deviation divided by the square root of sample size times the square root of the big letter n and i-minus natin yun dun sa sample size all over dun sa big letter n ulit minus 1 kung saan yung big letter n is yun yung total population. And after applying the correction formula, ang makukuha na natin is 94. Therefore, 94 yung magiging samples natin out of 185 clients. Lastly, para mas maintindihan natin yung impact ng precision and or yung confidence sa sample size, palitan natin ngayon yung confidence level. Gawin natin ngayon na 99% yung confidence. Gawin natin na yung manager will be 99% confident na yung expected monthly withdrawals will be within the interval of $500. Ano na ngayon yung sample size natin? Yun yung tinatanong. Pero linawin ko lang, i-disregard natin yung info dun sa case number 2 kung saan 105 lang yung total population. And okay, after nating mag-substitute, ang makukuha na natin ngayon is 325. If papansinin from 188 na naging 325 na yung sample size, yung sample size natin. Bale, di ba? Nag-increase ito ng nasa 1.73 times. Kaya it is good idea talaga na isipin muna natin kung how much precision and confidence yung kakailanganin natin before natin i-determine yung sample size. Kasi diba, tingnan mo, from 95% na nakuha natin is 188, tapos nung nag-99% naging 325, ang laki nung dinagdag sa sample size. Nakuha pa yun? Nakuha ba yun? Okay. Aside sa nagawa natin, sinabi din ni Sekaran and Boogie na maaari nating gamitin yung table na pinrovide or pinopose ni na Krejci, and Morgan as guide for sample size decision. Actually, yung table na to, up to 1 million yung total population. Pero sorry, hindi na nagkasya. Pero yung proposed sample size lang doon is at maximum of 384. And habang lumalaki yung population, papakonti yung pag-increase ng sample size na pwedeng gamitin. Next, dito naman sa sample size and type 2 errors, sinasabi lang na ang paggamit ng sobrang dami ng sample size, let's say over 500, could be a problem since prone ito sa pag-commit ng errors na tinatawag na type 2 errors. And ano ba talaga yon? Ano ba yung type 2 errors na to? It is a statistical term used within the context of hypothesis testing that describes the error that occurs when one accepts a null hypothesis pero it is actually false. So in other words, with too large sample size, kahit yung mga may weak relationships might reach significance levels, and mapapaniwala tayo na totoong may significant relationship nga yung mga nakita natin sa mga samples when in reality they may not be true. Ganun yung dun sa type 2 errors. Now, there are various rules in determining the sample size, right? But Roscoe, 1975, proposes the following rules, yung rules of thumb. Number 1, sample sizes larger than 30 and less than 500 are appropriate for most research. Kasi nga, di ba, may probability na mag-commit tayo ng type 2 errors kapag sumobra sa 500. Or kasi di ba, yung 500 sobrang laki na nun na sample size. Also, kapag sobrang konti naman is may risk na hindi nito ma-represent yung whole population. Second, where samples are to be broken into subsamples like, for example, male and female, juniors and seniors, it is necessary na at least 30 yung sample size for each category. Kapag naman daw sa mga multivariate research, wherein it involves the inclusion of more than one outcome in a singular analysis, the sample size should be several times, preferably 10 times or more as large as the number of variables in the study. So, yung ratio is 10 to 1, ganon. And for simple experimental research naman, with tight controls or tight experimental controls, like match pairs, ganyan, successful research is possible na kahit na small as 10 to 20 yung size. So, yun yung rules of thumb na pinropose ni Roscoe. And yung last topic sa sampling is the efficiency in sampling. It is a measure of the optimality of the sampling strategy. In here, sinasabi lang na some probability sampling designs are more efficient than the others. Like yung sa simple random sampling procedure. It is not always the most efficient plan to adopt. Yung stratified random sampling is often the most efficient, and dagdag lang sa mga sinabi ng mga previous reporters na yung disproportionate stratified is lumilitaw na mas efficient kumpara dun sa proportionate sampling design in many cases. Yung cluster sampling naman, on the other hand, is less efficient kaysa sa simple random sampling. Kasi there is generally more homogeneity or pagkakatulad among the subjects in the clusters than is found dun sa mga elements ng population. And mas efficient naman yung multi-stage cluster sampling kaysa sa single stage dahil there's more heterogeneity naman na nakikita doon o pagkakaiba. So, as a conclusion, always remember that the choice of sampling plan is depending sa mga objectives ng research natin, as well as doon sa extent and nature of efficiency desired. And that's it. Yun yung pinakatatandaan natin dito sa sampling. Hopefully, may natutunan kayo sa 2-part video presentation na to. And again, I am your winning student, Jericho Manalo. And gusto ko lang hiramin yung sinabi ni Nicholas Wirth na in our profession, precision and perfection are not a dispensable luxury, but a simple necessity. And kaboom! That's it. Thank you for listening. Bye.